As in our previous video we have learnt that why neutrons exist and how they are important for nuclear stability, but if neutrons are high, as in figure where carbon-14 isotope is shown with 8 neutrons as compared to 6 protons in nuclei, makes isotope unstable. To regain stability, nuclei try to minimize its number of neutrons or by emitting excess energy. This emission of particles from the nucleus is called radioactivity, and the isotopes are called radioisotopes. This decay happens 3 ways: alpha decay, beta decay, and gamma decay. Alpha decay is the spontaneous emission of alpha particles from the nuclei of an atom with emission of 2 protons and 2 neutrons, which causes decrease of 4 in mass number, and they are also called helium nuclei because of same mass number as to helium. For example, uranium-238, which is highly radioactive, and it decayed into thorium and helium nuclei. In the equation, one important thing we should notice is +2 charge on helium nuclei, which shows that the emitted nuclei is ion, not a neutral atom, because alpha decay only emit neutrons and protons. Uranium gets stable Bu decaying into thorium, whose mass number is 234, which shows uranium mass number decreases by 4. Let compared helium atom and nuclei, we can see that both have equal number of protons and neutrons, whereas in helium atom 2 electrons are present, but in helium nuclei no electron, which makes helium atom neutral due to 2 proton and 2 electrons, but only 2 protons in helium nuclei makes it ion with 2+ charge. A figure is showing this, where 2 electrons are revolving around the nuclei in their orbit, but in ion no electron is present. Now we will study the properties of alpha particle, where we first understand why alpha particles are helium nuclei. The answer is simple: due to the same mass number as of helium nucleus. The second property is that they have high ionizing power due to the presence of positive charge on them. Third and most important property is that they can be deflected by electric and magnetic field due to presence of positive charge as they move through field. For example, we have a positively charged plate and one is negatively charged. The reason behind only emission of alpha particles enter between alpha decay is that electrostatic repulsion with positive alpha of an atom not around overall atom. That's why it happens. The negative charged plate. Lastly, they have low penetrative power. The reason is their large size and presence of charge, which makes them less energetic, and they can easily stopped even by a paper.